and lavas in motion, remembering that as they do move, they're forming this solid rind as they go along. And so I've seen lots and lots of videos of pahoehoe, which just kind of spills like cold syrup across the surface.
Is that what we see in Hawaii?
Absolutely.
I saw it spilling into the ocean.
The Hawaiian vents do both, of course. And these are Hawaiian terms, and that's why you pronounce them in that fashion, every vowel. The pahoehoe is rather gas poor, and it turns out the level of gas content in the lava, in the magma, in the subsurface, partly goes to characterizing that material's viscosity. And so the thing you should tie into this is the higher the gas content, the greater the viscosity of the material. So pahoehoes are gas poor, they flow very smoothly across the surface, and the pahoehoe lavas have very smooth surface textures. The a'as are rather gas rich, and this process of trying to degas and move across the surface makes the surface of the flow break up. It tries to solidify, but it's in constant motion, constantly degassing, and the surface gets blocky, and it literally looks like a crumbling wall of rock as this molten flow advances across the surface. They're very wild looking. They don't look like they're actually in motion and actually moving. So those are typical of lavas. The lavas that we left at Rocky Ledge, pahoehoes. We saw bubble trails. Implies gas is there, but when we move to the a'a, the gas level is significantly higher. We can have magmas that are far more rich in gas than either of those categories, and we'll talk about those a little bit later on. As you move into some of the solid materials that get blown out of a vent, notice that they've got a few different categories here. Airfall fragments. And the airfall fragments, there's a bunch of different names for this stuff. Sometimes it's called tephra. T-E-P-H-R-A, tephra.
That's sort of the general name for all of that stuff that falls out of the sky.
Yes, that's absolutely correct. Materially that is explosively ejected from a vent, material explosively ejected from a vent is generally known as tephra. The term I typically use is pyroclastics, and that's my favorite. Fire fragment. So tephra, pyroclastic, airfall are ways of describing material that was explosively ejected. We categorize this based on size and partly based on the character of the material tossed out. Size-wise, it's dust, ash, cinders, blocks, and bombs. So we're going to be careful about our terms here. It turns out that you can toss out of a vent materials that are cinder-sized, but molten. Cinder's solid when it comes out of the vent. So it's blasted out, flies through the air, a solid material, lands on the ground, and already solid before it hits. But if you blast something out of the vent that's about that size and liquid and molten, it gets another name. It's called lapilli. L-A-P-I-L-L-I.
And that would be a pyroclastic product.
A lapilli is molten, pyroclastic material, flies through the air wet. It may partially cool in flight, but then impacts the ground, usually at least somewhat molten, perhaps plastic in character.
So would lapilli be cooler or hotter than cinder?
Yes, it would be. It would be hotter material. So you could actually have, during an eruption, cinder and lapilli coming out of the vent. Okay?
Is that a lapilli?
And so not everything falling from the vent would be solid. Some of it would be molten. When you get up to the size category of block, notice the size there, greater than 64 millimeters. So that's on the scale of around 4 inches and larger, 5 inches and larger, somewhere in there about 4 inches or so. close to 4 inches. Blocks are solid. Notice the same size term applies to bombs, but bombs are also molten. And so our lapilli and the bombs, both size terms, but bomb and lapilli is very specifically speaking to ejection of molten material. Okay? That material flies through the air because it's plastic or even largely molten. That stuff starts taking on an aerodynamic shape, okay, as it flies. Now, we've also said if it's being ejected from a cinder cone, it's rather gas-rich. Well, gases try to escape, but this stuff's flying through the air, and often it is spiraling in flight. And so now you've got molten rock flying through the air, trying to degas as it spins. Turn to page 6.
Can you spell it, Lapilli?
L-A-P-I-L-L-I. Check out page 6, figure 3-6. It's above our columnar joints there, right? Did I get everybody on the same page? And notice 3-6A and 3-6B. 3-6A is almost impossible to view, but 3-6B is very viewable. Look at our little lapilli and bombs here. Notice their shapes, they look like footballs. And they almost have this twisted character to it. You can actually see the lava appears to be wrapped around. I always think of it as a Tootsie Roll wrapper. These things are moving through the air, and as they fly, they're spiraling around. But what's really cool about them is that they're trying to degas as that spiraling is occurring in flight, and they'll make spiral bubble trails inside the bomb and inside the lapilli. So when we came out, that was my effort, was to hunt for some bombs. And so I found a couple. This is perhaps the best one initially to look at. And the bomb here, you can see that it's got, and some of this has broken away, but the bomb here has some very bubble-rich sections and some more solid sections that have largely degassed. Well, this thing was flying through the air and spinning in that fashion, and it's imparted a spiral bubble trail to its shape. You can actually see a couple of sections here. Almost looks like spiral galaxy lobes on this one. So there's a nice bomb to pass around. It's got a real sharp corner, so be careful. There's another, that might be the core of a bomb. I'm not quite sure on that one. But this is probably the biggest one I've seen so far. And you can see its shape.
Yeah, you can see the bubbles.
And you can see how that's oriented. Look how smooth on the degassed areas. But again, you can kind of follow these bubbles. The one that really caught my eye right off the bat, I think it's this one. Again, kind of a chilled surface there. But look at the bubble textures around here. Really, really, the term for a bubbly texture is vesiculated. So very vesiculated towards its core. You've got a progressively finer vesiculated texture towards the outer edge. But this is some of what is coming out of the vent behind us and the vents adjacent to us. As this thing fire fountains into the air, this stuff's being tossed out, some of it in a molten, semi-molten state that tries to degas in flight.
Is it hardened by the time it hits or no?
Sometimes they're somewhat hardened by the time they hit. Some of the bigger bombs, you can actually begin to look at the flank of the volcano now. As you start looking at the flank of the volcano, you can see there's some really big bombs around.
Yeah.
Now, while these aren't the most violent eruptions that we can talk about on planet Earth, you still wouldn't want to be around as these things are landing nearby. But lots and lots of bombs all around the whole thing. Some of these, of course, have tumbled out into the quarry debris here. And so one of the things I thought you guys might enjoy trying to look for is some bombs or some lapillis. See what you can find. Yeah, this could absolutely be one. Let's see. Ooh.